Good morning, children. Now we have to see the second lesson from science. It belongs to physics, motion. Motion, you know, what's the meaning of motion? Movement. There are two stages of a body. One is rest, other one is motion. First one is what I said, rest. There we will see what are the two stages, rest. Other one is motion. When the object is not doing any action, it simply takes rest. That stage is known as what? Rest. If the object moves from A to B, that is known as motion. So we have to see in this lesson what is motion, what are the laws derived from the motion, and how we can measure the motion by the different organisms. Okay. First we will see the definition. What is motion? Motion is change in position. What is motion? Change in position. Position is known as motion. For example, a particle, the particle A, this is the particle, it is in the place of A, because of force or something else, it moves towards and it goes to B. This is known as what? Motion. The object which is rested on the A moves towards the B. This is known as motion. This is change in position. Before that it was in A, now it goes to B. So this is the change in position is known as motion. This motion we can see it has some fundamental qualities. What are the qualities? Motion as distance. This is the distance travelled by the motion. First one is what I said, distance. Then distance travel in particular time. The distance travel and time taken is known as what? Speed. And travels in particular direction. This is velocity. Okay, yeah. Suppose the level of speed is increased, that is known as acceleration. These are the qualities of motion. That is, change in position is known as motion. Okay. So what are the things covered by the motion? Distance, the time taken. The ratio between the distance and time taken is known as speed. The increase in the speed is known as velocity. It shows different direction, mean that is acceleration. All these qualities are possessed by motion. Now we have to see in detail it is what it is. There are 4 types of motion. For example, a car. The car remains in one place, that is known as what? Rest. The car starts from Chennai to Coimbatore. Before that it was in Chennai, now it is in Coimbatore. The distance travelled by the car is, it is travel in particular time. So the distance between Chennai to Coimbatore and how much of time it has taken, distance by time taken, if you are dividing we can get the speed of the car and what direction it goes. Then how it is increased or not speed, this and all known as what? Acceleration and velocity. There are 4 kinds of motion. Based on rotating, we can say based on functioning, we can say 4 kinds of motion. So what are the motions? We have to see kinds of motion. What are the types of motions? On seeing the name itself, you can see what are the types of motion. One is linear motion. Another one is circular motion. Third one is oscillatory motion. The fourth one is random motion. Linear motion, you know, if it is travel in the straight line, this is linear motion. Circular motion, the fan and all, they are rotating, no? This is circular motion. Example, we can say what? Fan. Oscillatory motion, that is movement, that is pendulum or else swing. The to and fro motion of the object is known as oscillatory motion. For example, we can say swing. Swing means, you know, unjal. That is, it goes first and then come back. This is to, this is fro. To and fro motion of the swing is known as oscillatory motion. And the next one is random motion. Random motion means we cannot designate what kind of motion it is. It is bombarding each other. So they are dashing with all the particles together. This is random motion. So linear motion, it's in a straight line. Circular motion, I said it is circulated in particular thing. And oscillatory motion, there is a to and fro motion. And random motion, apart these three are not there. It is in any direction, any places. This is known as what? Random. Random motion, that is object, it does not fall in any of the above categories. Okay, so this is the kinds of motion. So based on the motion, we can further divide them into uniform and non-uniform. Uniform motion, and further we have to see what are uniform motion, what are non-uniform motion. Uniform, can you see what is uniform? In the school we are wearing, every day we are wearing the same dresses, that shows the uniformity. That is uniform, everyone from LKG to 10th standard they are following the same uniform. So like that, uniform motion means from, for example, 6 o'clock you have started from your house and you are going on traveling 6, 7, 8, 9, 10 and you are reaching the place at 10 o'clock. Till that you are going to the same speed only. For example, you have started with the speed of 5 km, 6 to 7 you are traveling 5 km, 7 to 8 5 km, like that equal distance, equal traveling time. Uniformly you are taking, that is known as uniform motion. For example, you see in your book it is given a car. A car is there, it covers 60 km in first hour, 60 km in second hour and 60 km in third hour. So how many kilometers the car goes? 3 kilometers. Okay, yeah. So 3 hours, how many hours it goes? 3 hours. In the first hour 60, second hour 60, third hour 60 kilometers. So totally it travels 180 kilometers. This is total distance. How many hours? 3 hours. This is 60 km per hour. Okay, this is known as what? Uniform motion. Suppose the same car, okay, it takes 100 meters in 5 minutes, it goes 100 meter, that is no traffic and all, traffic area, car goes in the traffic area, 100 meters only it can move in the 5 meters, in the 5 meters it can go, non-traffic area. Not traffic area, fastly it can go. The road is clear, so the car goes 100 meters in 5 minutes. The same car in the traffic area, so to cover the distance 100 meters, it takes, for example, 30 minutes. Is it uniform motion? In the non-traffic area, it takes only 5 minutes to cover the distance of 100 meter. In the traffic area, the same 100 meter, it takes 30 minutes. From that, what you know, this is non-uniform motion. This is not uniform motion. So there are two kinds of motion, uniform and non-uniform. We said the example, what is uniform motion and what is non-uniform motion. Clear? Now we have to see what is distance and displacement. There is a difference between distance and displacement. We will see what is distance, what is displacement. This is the actual length. Distance is actual length between the 2 points A and B. A is the starting point, B is the ending point. So that is arrival and departure. The distance between A and B is known as, this is the distance. And displacement, this is also the same distance only, it shows the direction. It shows same that is object move from A to B only, but it has a direction and it is velocity as well as magnitude. It is a square, distance is scalar quantity. This is displacement is vector quantity. It has velocity as well as direction. So distance, what I said, that is the place, actual distance from A to B. Displacement also same only, but says which direction it goes. It shows the direction also. In the distance there is no direction, so it is a scalar quantity. It is the vector quantity. We can say either it goes towards the east, towards the north, like that. Displacement, it has the direction. In the distance there is no direction. So distance and displacement, clear? Now we have to see what is speed, what is velocity, and what is acceleration. Speed I said. Already I said. Velocity in the particular direction. We have seen all those things here. Let me write there itself. Speed. What is speed? It is the rate of change, the distance travelled in a unit time. Distance travelled is known as what? Speed. Distance travelled. Speed is distance travelled by time taken. Already I said there, okay, the car travels 180 kilometers in 3 hours. So distance 180 by 3, that is 60 kilometer per hour, like that. Okay. Velocity, it is the rate of displacement. Velocity is what? It is the rate of displacement. I said already, it is a vector quantity. And acceleration, this is increase in the speed, that is change in velocity in the change in velocity and time. That is initial velocity to acceleration is initial velocity to final. This is acceleration. So according to the time limits, you may increase the speed or decrease the speed. This is known as what? Acceleration. For beginning, you are started with one speed. Then due to adjustment of the time, you may increase the speed or decrease the speed. That is initial velocity beginning and final velocity reaching time. The difference between that increase or decrease is known as what? Acceleration. So what are the three qualities of speed? Distance, speed, velocity, acceleration. All based on same only. There are three equations. So based on the distance can be followed by three equations. We will see what are the distance. You can draw the time graph also. Time graph you can draw. For example, you can take one side what? We can show that speed, I said no, speed and distance. You can show by the graph also. So how can you show the graph? For example, uniform motion. I say no, uniform motion we have to see. In one side you are taking time, other side distance. For example, 0 time, 0 meter, distance in meter. Then 5 minutes, 500 meter. 10 minutes, 1000 meter. 15 minutes, 1500 meter. 20 minutes, 2000. And 25 minutes. Already you are familiar with the graph, correct? So in one side, for example, this is graph. In one side you have to take seconds. Here we are taking, this is x axis, this is y axis. Zero, this is x, this is y. Here we are taking what? Time. So how many minutes there? 5 minutes, 10 minutes, 15, 20, 25. 1, 2, 3, 4, 5. 5 minutes, 10 minutes, 15, 20, 25. Here distance 0, 500, 1000, 1500, 2000, 2500. Okay, yeah. The first 0 only. The first 5 minutes, what is there? 500. So you have to see where is 500. In second 10 minutes, that is 1000. Sorry, 5 minutes only 500. In the 10 minutes, 1500. Where is 1500 and 1000? Here. 500, 1000, and the third one 1500. The 20 minutes, what is there? 2000. 25 minutes, 2500. So your taken means this is what? Uniform velocity. This is uniform. Clear? We have to write the graph. You know the scale, x-axis 1 centimeter is 5 minutes. In the y-axis 1 centimeter is 500 kilometers. Like that you have to write. The same like you can write non-uniform graph also. Non-uniform graph you can do like this. Non-uniform motion. The same like what I said. The same, for example, time you have taken 0 second, time, here distance to 1 meter, 4 meters, 6 9 meters, 8 16 meters, like that going on, irregular. The same like x-axis, y-axis 0. Here you are taken what? Seconds. The distance. What are the seconds? 2, 4, 6, 8. Here 0, 2, 0, 1, 2, like that, 3, 4, 5. There is no place to do like that. Okay, for example, at least one we will say 0. The first and the 2 minutes, what is to second what is there? 1. The fourth minute it goes 4. So this is irregular. This is known as what? Irregular graph. So uniform motion, uniform motion is the non-uniform motion, that is non-interval of time. And we have to see what are the equation of motions. Equation of motions, and there is no time for me to take now. Let me continue in other class. Clear, children? What are the things we have seen now? What is motion? What are the types of motion? Then what are the differences between uniform and non-uniform? What is distance and displacement? And speed, that is speed, velocity and acceleration, all the things we have seen in clear. And we have presented the graph also, how to draw the graph for uniform and how to draw the graph for non-uniform motion. Let me continue what are the equations of motion in next class.